Welcome to the Scholar's Air tutorial. In this video, we will be looking at logarithm, how we can solve questions under logarithm. So before going ahead to solve questions, let's look at some key things in logarithm. Assuming you have something like this, log a to a base b equals s. Now in order to find s, or in order to find a, there is one thing you should know, that for you to get a, just do b to the power of x, you will have a. B to the power of x and we have a. That's if we have log a to the base b equals s. So imagine you are asked to find x. You are given something like that and you are asked to find s. What you just have to do is, what power will b be raised to that will give it a? Okay, let's simplify further. So this is what I mean. B to the power of x will give it a. If you have something like this, you have b to the power of x will give you a. Now let's look at an example. Let's look at an example real life working. Log 32 to the base 2. We have log 32 base 2 and we are asked to find s. What you just have to do is 2 to the power of x will give you 32. So what is that number that 2 will be raised to make it 32? That number is 5. 2 raised to the power of 5 is 32. Therefore x is equals to 5. You can see it's very easy, because 2 to the power of 5 is equals to 2. I don't know if you understood. Let me explain. Log a base b equals s. This, to find a, or to find a, what you just have to do is b to the power of x will give you a. Now if you are asked to find x, if you are given log a to the base b, you are asked to find x, what you just have to do is, what is that number that b will be raised to give it a? And we look at an example here. Log 32 base 2. Now we need to find s. What is that number that 2 will be raised to give it 32? And we know that 2 raised to the power of 5 gives us 32. Therefore x is equals to 5. Very simple. Now let's look at some laws of logarithm. Let's look at laws of logarithm. So I'll be listing out the laws and I will explain with examples. So number 1, we have addition law. We can also call this product law. Now this law says that if the bases are the same, and you have to add the logs, what you have to do is what? To multiply these numbers. So just pick one of the log, pick one base, which is a. Assume we have log m to the base a plus log n base a. So just pick one of the log and pick a base, which is a. Then we multiply these numbers m and n. So we'll be having log a m times n. That's for addition law. Now let's look at an example. So looking at an example, we have log 5 base 3 plus log 10 base 3. Now to solve this, you just have to pick out log 3, since they are the same base. Remember, we are adding, there is an addition law. We pick out log 3, then we do 5 times 10. 5 times 10 is what? 50. So we have log 5 times 10 to the base 3, which will give us log 50 base 3. That's how the addition law works. Now for this first one I gave you guys. Now let's verify it, because some of you might be having doubt. Let's verify it using the calculator. So this is my calculator. Let's verify this. We say log 2, log to the base 2 and 32 here equals, you can see we're having 5. So the stuff we established initially is very correct. Now let's look at the second law. The second law of logarithm, we have the subtraction law. So for the subtraction law, when we have log m base a minus log n base a, what you just simply do is pick out one base and pick out log. So we have log a, then you divide these numbers. So log a m divided by n. So looking at an example, we have log 24 to the base 5 minus log 4 to the base 5. So what you just have to do is to pick out log 5, which is here, and we divide this number, 24 divided by 4, and we have log 6 to the base 5. So subtraction law and addition law can only be applied to logs that have same base. Assuming we have 4 here and 3 here, we can't use this addition law or subtraction law. So we only use this law when the bases are the same. So the next we have is the index law. We can also call this the power law. The log of a power is the exponent times the log of the base. Looking at this, we have log m base a to the power b. Writing this, we will bring this b to the front. We will bring this b now as a whole number to the front, multiplying the remaining terms. So we are not changing the position of this b. This b was the power now, but we are now bringing it to the front here to multiply the remaining terms. That is what this index law means. Let's look at an example. So here we have log 5 to the power of 3 to the base 2. What you just have to do is to bring this 3 to the front here, which we did here, and to multiply log 5 base 2. That is just everything about the index law. Bring this 3 to the front here, and it will multiply the remaining terms, log 5 base 2. So don't forget, first we have the addition law, we've treated subtraction law, now index law. So the next one will be treating the log of 1 to any base is always equal to 0. Assuming we have log 1 base 32, the answer is 0. So the base must not be equal to 0. This only applies if the base is not equal to 0. So if we have maybe log 1 to a base 0, this law will not stand. But when we have log 1 to a base 32, log 1 to a base 2, log 1 to a base 3, then this law stands. I don't know if you got me correctly. The log of 1 to any base that is not equal to 0 is equal to 0. Next one is the log of a number to its own base is equal to 1. So if you have log a base a, the answer is 1. Log 3 base 3, the answer is 1. So the log of a number to its own base is always equal to 1. So the last law of logarithm we'll be looking at is this one. We call it change of base. So the last law of logarithm we'll be looking at is this. We call it change of base formula. Now how does this law apply? When you have log a to a base b, and maybe you want to change this base to another base, like you want to change it to d, what you just have to do is take log d, which is the new base, take log a to a base d, which is the new base. So take log a to a base d, which is the new base, divided by log b. B now was the old base, so you are not taking it as log b to that what new base. I don't know if you understood me. You want to change the base now in this log a base b. You want to change this base to, let's say, d, you don't want the base to be big, you want it to be d. What you just have to do is take log a to that new base, which is d. Log a to the new base, which is d. So we have log a to base d divided by, take log b. Log b now is the old base. Take log b now to the base, which is the new base, d. So we are having log a base d divided by log b base d. Very simple. Let's look at an example. So looking at an example, we have log 5 base 3. Now assuming you want to change this base from 3 to 2, all you have to do is take log 5 to base 2. Base 2 is the new base, divided by log 3, which is the old base, to base 2, which is that new base, and from there you can solve. So this is the last law of logarithm. Remember the first law, which is the addition law, where if you have logs with the same basis, adding, you just have to take the numbers and multiply them. Pick out one log and multiply the numbers. For subtraction law, as far as the bases are the same, pick out one base and divide the numbers. So you divide. For index law, take the power, this power, bring it to the front to multiply the remaining term. So you are taking this to multiply this. Then for this one, log 1 to any base is always equal to 0, and log of a number to its own base, so log a base a is equal to 1, so log 3 base 3 is always equal to 1. And for change of formula or change of base formula, what you have to do is log a to the new base divided by log b to the new base. It's very simple. Log a new base. Okay, let me just give this guy something. Now let's say you want to change this now to d, so log a to new base, log b to new base. So you are working with these two terms to the new base. Take log a to the new base and log b to the new base. Very simple. Now we are done with exploring the laws of logarithm. Let's see how we can apply these laws in solving questions under logarithm. So we have these three questions. First one says log 9 base 3 plus log 15 base 3 plus minus log 5 base 3. Second one, half log 25 minus 2 log 3 plus log 18. And the third one, log 8 minus log 4 divided by log 4 minus log 2. So if there is one thing you should notice in these three questions, is that they all have the same basis. They are all in the same base. So let's see how we can solve all of them. Let's start with the first one. So this is our first question. Now recall what I said in the laws of logarithm when we talk about addition law and subtraction law. So we'll be applying that here. Since the bases are the same, we'll pick out one, then we would multiply these two numbers since they are adding, then divide by 5 since we are subtracting here, so we divide by 5. Watch out. So we'll be having something like this: log base 3 into 9 times 15 divided by 5. How can we rewrite this? We can write this by bringing it as our denominator. So we have log base 3 into 9 times 15 divided by 5. Now 5 into here 1, 5 here is how many? It's 3. So we're having 9 times 3. So if we multiply this 9 times 3, we have log 27 to base 3. Now we will not just stop here because we have 27 here. Let's see how we can simplify this. If we are to write this in indices, 27 in index form, we know that 3 raised to the power of 3 will give us 27. So this 27, I will replace it by 3 raised to the power of 3. So we'll be having this. Now recall in index law where we talked about having a power. What you have to do, we say bring this 3 to the front here to multiply the remaining terms. So we'll be having 3 log 3 base 3. So this is what we'll be having. Recall also that I said log of a number to its own base is equals to 1. Now we look at what we have in here, log 3 base 3. That means log 3 base 3 what is equal to 1. So we'll be having 3 into 1 since log 3 base 3 is equal to 1. So if you're having this, 3 times 1 is 3. So 3 is our final answer for this particular question. Now recall all the steps. First, we pick out the base, multiply this and divide by this. After dividing, we had log base 3 9 times 3, which gives us log 27 base 3. We express this as indices where we had log 3 to the power of 3 base 3, and we say that log 3 base 3 equals 1, and we bring this power to the front, so we are having 3 log 3 base 3. Since log 3 base 3 equals 1, we replace it with 1, so 3 times 1 is equals 3. That's how we arrived at this final answer. Let's look at question 2. So our next question is 1/2 log 25 minus 2 log 3 plus log 18. Looking at all of these, they are all in base 10. So first of all, we collect like terms. The one that have plus, we bring it here, and the one that have minus, we send this to this side. Next thing is, looking at this, we have 1/2 log 25. Remember, in index law, when we have log 25 to the power of 1/2, you bring the 1/2 to the front. So now that we have 1/2 to the front, we will make it the power. We bring it back as the power. Then for this, we also bring it back as the power. So we will be having log 25 to the power of 1/2 plus log 18 minus log 3 to the power of 2. Next is, whenever you have anything to the power of 1/2, it means square root of that thing. So 25 to the power of 1/2 means square root of 25, which is 5. So we'll be having log 5, and 3 to the power of 2 is what? 3 to the power of 2 is 9. So we'll be having 3 times 3, which is 9. So we're having log 9. And we have this log 5 plus log 18 minus log 9. Now we can use the addition and subtraction law to solve this. Since they are the same basis, we pick out one base and add these numbers, and we multiply these numbers and divide by this. So we'll be having log 5 times 18 divided by 9. Now here 1, 9 to 18 is what? 2. So we'll be having log 5 times 2, and 5 times 2 is what? 10. So we'll be having log 10. So we'll be having log 10. Now remember that I told you guys that these ones that did not give us the base, they are all in base 10. So there's an invisible 10 here, so we can rewrite this as log 10 base 10. So since we have this as log 10 base 10, remember the law that I said, when you have a number to its own base, the answer is 1. So log 10 base 10 will give us 1. So here we have our final answer as 1. Remember the steps. First of all, we bring this plus to this side and take the minus to this side. Then we take the numbers as powers. Remember, in index law, take these numbers as powers, and 25 to the power of 1/2 represents square root of 25. So square root of 25 is 5. 3 times 3, which is 3 raised to the power of 2, is 9. So we bring in addition and subtraction law, and to give us log 10. Log 10 base 10 equals 1. Now let's look at question 3. So for our question 3, we have log 8 minus log 4 divided by log 4 minus log 2. So we're using the subtraction law here. So log 8 minus log 4, we pick out, they are all in base 10, remember. So we pick out one of the base, then divide these two numbers. So we'll be having log 8 divided by 4 divided by log 4 divided by 2. 8 divided by 4 is 2, 4 divided by 2 is 2, so we'll be having log 2 divided by log 2. So log 2 divided by log 2 is what? Is equal to 1. So log 2 here will cancel, log 2 here will cancel, and we have just 1. So 1 here is our final answer. Remember the steps we used to solve this. So this is how we can use to solve questions under logarithm.